15,000 men at that time, many of whom worked on Titanic over the 26 months it took to construct the hull for launch. At the Harland and Wolff shipyard in Belfast, there was a 6,000-ton structure which was over 200 feet high. It was known as the Irlande. The gantry was constructed to house two massive ships that were being built for the White Star Line. It supported the giant cranes that lifted materials and equipment into the ship's hull using steel and rope slings made on-site by the yard's rigging teams. Housed in the Irlande gantry was a Harland and Wolff ship with the yard number 401. It became known the world over as Titanic, the largest passenger liner in the world. Began with the keel being placed on a series of wooden blocks laid on the slipway. These were made of pitch pine and were stacked about 4 feet high with angled wedges on top. On these were laid the first steel plates. The plates were strengthened on the bottom by a flat slab keel bar, which protected the bottom of the ship. On top of the steel plates, a 6-foot-high solid spine was laid, which ran the length of the ship and was known as the vertical keel. The vertical keel had a rigid rib of plates which ran along its spine. At the base was Titanic's double bottom. Here the hull was made up of 2 layers of steel plates, in some cases forming enclosed tanks and coal bunkers. Along the hull were the steel frames that made up the skeleton of the ship. The frames were curved to give the hull its shape and were positioned between 2 and 3 feet apart. The ship's frames started out as straight bars. These were heated in a furnace, then hooked out onto slabs of cast iron, where they were hammered into the required shape against an iron mold. The frames tended to straighten slightly as they cooled, so the frame benders gave it a little more curve than needed and hammered it into the finished shape before it was too cool to bend. Lowering the frames into place was a dangerous process until they had been firmly joined up by the horizontal girders called stringers, which locked them into position. Then the shell plates that made up the hull were riveted onto the outside. Plates on the hull of Titanic were 30 feet long and were laid in 2 ways. At the sides, the shell plates were alternately sunken and raised, known as inner and outer strakes. At the bottom of the hull, the plates were attached using the clinker method, where each plate overlaps the previous. Every plate had to be riveted in place, which was partially mechanized and partially done by hand by riveting squads. The riveters worked in teams of 5. On one side of the plate, the iron rivets were heated on a portable hearth by the heater boy. Using tongs, he threw the rivet to the catch boy, who placed it in the hold for the holder up, who held the head in place with a hammer. On the other side of the plate, 2 men worked with hammers to fit the rivet tightly into a pre-punched hole, then chipped off the surplus material. To make the process quicker, the best teams used 1 left-handed and 1 right-handed riveter. They then marked each finished row with chalk. Were made steel, which were then plated over to form the decks. The exterior decks were clad in yellow pine and caulked so they remained waterproof. The decks were arched, known as camber, so that any water would run to the channel waterway and drain overboard. The wooden decks were mostly laid in pine and were secured to the steel plating beneath by bolts. The decking ran lengthways parallel to the center line of the ship. Of the ship were massive castings that supported Titanic's rudder and propeller shafts. These were made off-site by the Darlington Forge Company. The center propeller shaft passed through part of the cast that supported the rudder. It was known as the stern frame and was the hinge which allowed the rudder to steer the ship. The outer propellers were held clear of the hull by propeller bosses. The rudder was built of 6 steel sections. The rudder frames had to be enormously strong to withstand the force of the rudder turning in heavy seas.